Okay, so I wanted to take a look at kind of talking through this normal curve stuff. So suppose we have a mean mu, that's pronounced mu, it's spelled mu, mu of 40, and a standard deviation sigma of 8. If we have an observation, a single observation of 52, we might first want to find a z-score. So this is standardizing our observation. So z for a single observation is going to be x minus mu. So this is basically saying how far away from the real mean, right, the center of our data, is our observation. And then we're dividing by, in this case, if it's a single observation, we're just dividing by sigma. So z gives us a number of standard deviations from the mean. So we're basically taking a raw observation, x, and our raw mean and standard deviation, and we're standardizing it. So this allows us to compare across different distributions. And so we're just saying, okay, our observation 52, how many standard deviations is it away from the mean? So we'll find a z-score. So we just plug in our various pieces. So 52 is our observation, 40 is our mean, and then 8 is our standard deviation. So if we work through all of this, you can calculate this thing, just be careful about parentheses. We would get 1.5. Now, if z is positive, that should mean our observation is above the mean. And sure enough, 52 is definitely above 40. If z is negative, that means we're below the mean. So we've got a positive value, so everything looks like it's in good shape. So this is just the z-score. If we want to know what's the probability of getting a score like this, right? So if we want to know what's the probability that we would have an x value that's at least as large as 52, right? Well, this is one way to write it, that our observation, what's the probability of getting an observation x that's at least 52? Another way to say this would be, what's the probability of getting a z-score of at least 1.5? The only difference in these is, well, we can calculate them slightly differently. Certainly we have our table that allows us to start from a z-score and find a probability. But these two, if we visualize them, look very similar. So we have a normal curve, so it's this, this bell-shaped curve. The difference is, for the first one, we're looking at the raw data. So we're saying, okay, the mean was 40, our observation is 52, so we're trying to find the shaded area in the tail over there. In the standardized version, the standard normal curve has a mean of 0 and a standard deviation of 1. So 1.5 is going to be out here somewhere, and we're just trying to figure out what's the weight in that tail. So what is the likelihood? So we can use our table. We could also use a calculator. So let me see if I've got mine around here. So if we use a table or a calculator, let's see, we should have something like 0.0668. So the probability that we get in here, 0.0668, whether we've put it in with the raw data or the standardized data, we should get the same value. So 0.0668 or 6.68%.